Good morning, everyone. Myself Gautam Sharma. I welcome you all in a Sapience Education. So today I am going to discuss about the NCERT solution for the oscillation chapter. We will all discuss each and every numericals. So these numericals are done as per the latest guide of the 2023 as well as 2024. Now the question number first is, which of the following example represent the periodic motion? First is a swimmer completing one return trip from one bank of a river to the another bank. So first of all, see here what is the condition. So there is a swimmer and there is a one bank. So a swimmer just go and return back. So it is not repeating. It is not repeating. It is not repeating. So it is non-periodic motion. Now it is a case of in question number 2. A freely suspended bar magnet displays the north-south direction and released. So let us assume that there is a bar magnet. There is a bar magnet and it has been suspended freely. Okay. So let us consider there is a north, north and south pole. There is also another side, there is a south pole. So you know that freely suspended bar magnets always align toward north-south direction. Toward north-south direction. Now what happens when we displace it? Let us consider if we displace by some angle, then what will happen? It will again try to come in its north-south direction position. For example, this is your north and this is south. So what will happen whenever I will move? So again it will try to move, come back in its original position. Okay. So it means that it will be in a repeating as well as repeating, and there is always a acceleration is proportional to the negative of displacement. So it means that it is periodic and simple harmonic motion. Okay. Now the third question is, a hydrogen molecule is rotating about its center. So let us draw the hydrogen molecules. So there is a hydrogen molecules, H2 molecules, and it is being rotating about its center. So it is doing complete one cyclic motion. So I hope its answer will be periodic only, but not S.H.M, because it is not in the form of acceleration. F or force is not proportional to the displacement. So it means that it is your periodic motion. It is a periodic motion. Okay. Now question number D. In question number D, an arrow is released from bow. So let us consider an arrow is released from the bow. What will happen? When it will go, it won't come back. So it means that non-repeating nature. So it is your non-periodic. It is a non-periodic motion. Okay. So I hope you have understood that which is periodic and which is non-periodic. Now let us solve question number 13.2. 13.2. Which of the following example represent nearly a simple harmonic motion and which represent periodic but not S.H.M? So in simple harmonic motion, condition for S.H.M, you should always know that condition for S.H.M is force is directly proportional to displacement but in negative direction. So F is equal to minus kx. We can also put here mass into acceleration is proportional to minus x. So here acceleration is also proportional to x because mass will remain constant. So these are the condition for the S.H.M. Now periodic motion. Periodic motion means it has time period. Periodic motion. Periodic motion means it has time period. So it has time period. It means that it will repeat its motion itself after regular interval of time. Now let us do the question number A. The rotation of Earth about its axis. So as you know that Earth is being rotated about its axis. So there is no force which is acting against it. So it is periodic but not S.H.M. Periodic but not S.H.M. Okay. So I hope you have understood this because it is repeating motion. So that's why it is periodic, but there is no force acting which opposes its motion like this. So I hope you have understood this. Now let us do question number B. The motion of an oscillatory mercury column in a YouTube. So let us consider there is a YouTube. There is a YouTube. And in this YouTube, there is mercury. And one side there is a high level of mercury. What will happen? What will happen when we suspend it freely? So what will happen? It will move up and down at a regular interval of time. So it is repeating as well as up and down motions are there, and there will be an always a force which will always act up in downward direction, and when it will go up, so it will force will act on a downward direction, and when it will move down, so the force will act on a opposite direction. So there is always a negative force which is acting on its movement. So it is your periodic as well as it is a periodic as well as S.H.M. Periodic as well as S.H.M. Okay. So I hope you have understood this. Now let us go for question number C. Question number C. A ball, motion of a ball bearing inside the smooth curved ball. So there is a smooth curved ball. There is a smooth curved ball like this, and there is a there is a ball bearing. So what will happen if you release this ball bearing? So what will happen? It will go in this direction. Again, it will come back in this direction. So it will be repeating. As well as whenever it is moving, so what will happen? A force will act. For example, it is moving in this direction, so the gravitational force will try to make it stop. So always force will act all on a downward direction. So it is your periodic. So the motion is periodic and simple harmonic motion. I hope you have understood now let us discuss about question number D. Question number D, it is general vibration of a polyatomic molecules. See, if there is polyatomic molecules, so what will happen? Molecules are having a polyatomic molecules are there. So each will move in its own pace, in its own frequency. Okay. So each molecules will be vibrate. So each molecule will have each molecule have will have its own frequency. Its own frequency. Right. So it means that overall, when we talk about overall motion, it is not periodic motion. Since every molecule has its own frequency C as well as different degree of freedom or several degree of freedom. Several degree of freedom. So superposition of different S.H.M will not give an S.H.M as output. So hence it is non not not an S.H.M. Okay. So I hope you have understood this. Now let us go for a next question. The next question is in a figure 13.18 depicts that xt plot for a linear motion of the particle. Which of the plot represent a periodic motion and what is the period of motion in case of periodic motion? So periodic motion, what happens? We know that periodic motion means what? Motion should repeat. So it is going upward, so it is not repeated. It is not coming back. See, the object is not coming back with the time. Coming back to its initial position. So it is not periodic. Periodic means always try to understand that it is repeating motion. So the answer for this will be not periodic. Okay, so I hope you have understood this question. Now we need to find the same for the same the question. It is part B. So is it repeating? So from figure, when we see that straight line and again same is following, straight line same is following. It means that it is a repeating one. So since it is a repeating, hence it is periodic motion. Now for periodic motion, we need to find a time period. So when we talk about time period, so when we see that when it is repeated, see at this point from -3 to -1, -3 to -1. The time period is how much? Time period is how much? 2 seconds. So for this, time period is 2 seconds. So we have an answer for time period. The time period T is equal to 2 seconds for part B. Now see here. As per the question, as per the graph, we see that the object is behaving coming to the initial position. So should we write it as a periodic motion? We can't say. Why? Because it is not repeating at the same time. It is not repeating the same path, not coming at the same interval of time. So that's why it is non-periodic. It is non-periodic motion. Okay. Now let us go for this. So from this we can definitely we can say that it is a periodic motion because motion is repeating at a regular interval of time. So motion is repeating at regular interval of time so it is periodic. So it is periodic, and see the periodic. So if it is a periodic, so it will repeat its motion after 2 seconds. So the time period for this is also 2 seconds. Okay, so I hope you have understood this graph. Now let us do question number 13.4. So 13.4, which of the following function of a time represent a simple harmonic motion? B, periodic but not S.H.M. C, non-periodic motion. Give the period for each case. Periodic motion omega is any positive constant. So let us solve question A. So A question is sine omega t minus cos omega t. Is it periodic or not periodic? Since we know that sine omega is periodic, cos omega t is periodic, and periodic minus periodic will be periodic or not? Periodic minus periodic minus periodic is equal to periodic only when frequency is same. Only when frequency is same. So here frequency is same. Only when frequency is same. Since frequency omega t, see here, omega t for both the cases are same. So frequencies are same. See, frequencies for both are same. Here frequency for both the trigonometric function are same. Trigonometric function are same. So it is periodic motion. So it is periodic motion. Okay. In another way, we can also see. In another way, we can also do this. Just we assume that we know that formula sine a plus minus b is equal to what? Sine a cos b plus minus cos a sin b. Okay. So put the values and put why we can't do this for this. If we apply the formula, so sine omega t into 1 by root 2, if I will multiply minus plus minus, or if we have a minus, so we will use here minus only. We will use here minus only. So let us use here minus. So if I will use it as a minus, so this will be cos A. Cos A we have already cos omega t into 1 by root 2. And this whole can be multiplied by root 2. So this above function can be written as root 2 into sine omega t into cos pi by 4 minus cos omega t into sine pi by 4. Okay. So if we combine this, so we have a equation 2 into sine omega t minus pi by 4. So this is a single S.H.M equation only. Okay. Since this is an S.H.M equation. Okay. So I hope you have understood this question number A. I hope you have understood now. Now let us go for a question number B. For this, we need to find the conclusion is that it is periodic and S.H.M. Okay, and if we talk about the time period, so the time period for this is how much? Time period for this is how much? Omega. It's not omega, it is a time period is equal to 2 pi by omega. Time period is equal to 2 pi by omega. So we have a time period t is equal to 2 pi divided by omega. So this is the time period for this question. Now let us do question number 2. This sine cube. So let us see here. Y is equal to sine cube omega t. Now we know that y is equal to sine omega t is S.H.M, but y is equal to sine cube omega t is non-S.H.M. So if we want to split it, so what will happen? So we know the formula sine cube omega t is equal to 1 by 4 into 3 sine omega t minus sine 3 omega t. Okay, here here each function has here each function has different each function has a different time period. So if each function is SHM, each function is SHM, then a resultant function is not non-SHM because it has a different time period. So that's why it is your not SHM, not SHM. But it is your periodic motion because motion will repeat. So the if we go for the time period for this case, so t1, suppose it has time period t1, it has time period t2. So can we find time period for equation 1? So time period t1 is equal to t1 is equal to 2 pi by omega. And what about t2? T2 has a time period of 2 pi by 3 omega. So the suffix is 3 omega. That's why time period is this. Now resultant time period is equal to take LCM of both T1 and T2. So LCM of T1 and T2 is 2 pi by omega n comma 2 pi by 3 omega. So our time period will be required time period for net time period will be equal to 2 pi by omega, which is our required result. Okay. So the conclusion is conclusion periodic with pi by omega period, but not S.H.M. But not S.H.M. Okay. Now let us go for a question. Third question. Third question. The given question is C y is equal to 3 cos pi by 4 minus 2 omega t. So we can also write here 3 cos 2 omega t minus pi by 4. Okay. So this is an S.H.M. equation, periodic, and the time period for this is 2 omega. Okay. So this is very simple. Not 2 omega, sorry, it is not 2 omega. Basically, time period has a formula. Time period t is equal to 2 pi by omega, 2 pi by omega. But here in place of omega, we have a 2 omega. So 2 pi by 2 omega. So this will be pi by omega. So this will be the time period. Okay. So I hope you have understood now. Now let us go for question number D. In question number D, what exactly they have given? Question number D, y is equal to cos omega t plus cos omega t plus cos 5 omega t. See here, all are different S.H.M. So all are periodic because they will repeat itself. So this equation is periodic, but not S.H.M. But not S.H.M. Because each entity has different frequency. So if each entity has a different frequency, so that's why it has a net frequency, net resultant amplitude, and resultant function is not a S.H.M. Now, what is the time period? So let us go for a time period. So let us consider time period for this one is T1, T2, and T3. So the time T1 is how much? T1 is cos omega t. So T1 will be equal to how much? 2 pi by omega. T2 is equal to how much? Pi by 3 omega. T3 is equal to how much? 2 pi by 5 omega. So the lowest common factor is 2 pi by omega. So the time period you can find out easily here. Okay. Now we have to move to next question. It is E, and the exponential function e to the power minus omega square t square is what? See, you know that it is t square is positive. This will be negative. So the exponential, this is an exponential function. Exponential function, and it won't be repeated. So it is your non-periodic, non-S.H.M. Okay. Next is f. F is 1 plus omega t plus omega square t square. It is quadratic function, and it will go on increasing. It will go on increasing with the time, increasing with time, so it is non-periodic. Okay, because it is non-repetitive. Non-repetitive. I hope you have understood this. Okay. Now let us go for question number 13.5. So this is a particle is in linear simple harmonic motion between 2 point A and B, 10 centimeter apart. Take the direction from A to B as a positive direction and give the sign of the velocity, acceleration and a force on the particle. Okay. So they are simply giving us a particle. Let us consider this is the particle and it is moving to and fro, and this is your A and this is a B. Okay, basically it moves this direction as well as this direction. Take this direction as positive, this direction as negative. Okay, so since this is your S.H.M simple harmonic motion, we need to find the we need to find we need to find velocity, symbol of the velocity. We need to find symbol of acceleration. We need to find a symbol for force. Now see here at the end of the A. So let us consider when at the end of the A. So at the end of the A, so if an object is here, so what will happen? An object is here, so what will happen? Its velocity will be 0. Acceleration is toward this direction. So this direction acceleration should be positive. Now the force is also acting toward mean position because this is your mean position. So force will always act toward mean position. So the force is mean position toward mean position means it is this direction force is acting. So this is also a positive one. Now let us go for A. It is your answer. It's answer A, and now go for B. B at the end of the at the end B. So at the end of the B, if it is object is here, so what will happen? Velocity will be definitely 0 because it is at extreme position. Now the acceleration or a force is acting in this direction, so acceleration will also act in this direction toward mean position. So definitely here acceleration will be negative as well as force will be negative. Now let us go for a situation of a C at the midpoint between A and B. So if an object is here midpoint between A and B, so what will happen? Velocity is maximum, that is velocity is positive. But acceleration as well as at the midpoint of A, B and going toward A. So if an object is going toward A, so velocity will be negative here. But at the mean position, acceleration is 0, force is also 0. You know that there is no force acting either in this direction, this direction. Now let us go for D. In D, it is at a 2 centimeter away from B. 2 centimeter away from B, B and going toward A. So let us consider this is 2 centimeter away from B and going toward A. So if it is going toward A, so the velocity is negative, definitely its velocity will be negative. acceleration, so it is going toward mean position, so the acceleration is acting in this direction, force is also acting in this direction, so both are in negative, right? Now let us go for a E and F. So let us remove these things so that we can get E. Now let us go for a question E, situation E. E at a 3 centimeter away from A. So let us consider this is the where 3 centimeter away from A and going toward B. So it is going toward B. So what will happen? So velocity is in positive direction. So the final E is your positive velocity. And what is acceleration? So acceleration is also acting in this direction toward mean position, and force is also acting in this direction. So if both force as well as acceleration is acting in this direction, so what will happen? It will be positive. This will be also positive. Okay. Now let us go for a situation F. And situation F, it is your 4 centimeter away from B going toward A. Since it is your 5 centimeter, so 4 centimeter will be definitely at this point. See here, the distance between them is how much? 10. So this distance is 5. So definitely 5 centimeter position means away from the B is in this direction. So this is the acceleration direction, force direction, and it is going toward A. So everything will be again negative. So for F, velocity will be negative, acceleration will be negative, and force will be also negative. So I hope we have done all the questions of 13.5. Okay. Now let us go for a 13.6. Question number 13.6, it is saying that which of the following relationship between the acceleration A and displacement x of the particle involves simple harmonic motion. So for simple harmonic motion, for S.H.M, what we know is that force is directly proportional to the inverse negative of displacement. So if we remove this, so force will be equal to minus of the kx. Now if we re-equate this equation, force is equal to ma is equal to minus of the kx. So if this is also a constant, so we can write here force acceleration is equal to minus capital K into x. This is small k and this is capital K. So the equation is in this form is only following the S.H.M. So let us go for one by one. A is equal to not minus sign, negative sign. So this is not an S.H.M. Acceleration is minus is there, but it's a square term. So this won't work. So see, the question is A minus is there and X is directly proportional. So this will be the correct answer. And A is equal to 100x cube. So this won't work because neither it is minus, neither it is X proportional. So I hope you have understood this. So the final answer for this is C, that is equal to A is equal to minus 10 x, where K is equal to minus 10. Okay. So acceleration is proportional to negative of x. K is not minus 10, K is equal to 10. So I hope you have understood this question. Okay. So thank you for watching this video. So I should end up for today here. I will come up with the next video from 13.7. So you have enjoyed these classes. Thank you for watching my video.